Hello, everyone. This is Bob Martin, the RCSubGuy with the NautilusDryDocks.com. It is, what is it? It is Wednesday, 7 p.m.-ish on a beautiful February evening here in Naples, Florida. Thank you for joining me again. We're going to take the next short while. We're going to talk about RC submarines as per usual. Want to encourage everyone, if you have questions, be sure to pop them into the chat box there. I'll check through as I go and try and answer anything that comes up as it comes up. And if you have anything to chime in, because I do not profess by any stretch of the imagination to know everything, if you know the answer, then absolutely chime in and I'll bring it to everyone's attention. Hey, while we're waiting for everyone to join us here in the RCSubGuy live chat, why don't I do my typical thing and we will talk about what I got going on, what's on the bench right now. So we'll grab the phone and we've got this beauty. Now, I just did or I will be posting up a video on this shortly. This is an OTW Valiant class submarine, OTW out of the UK. I rep their kits here in North America. They are great stuff. Bob Dimack does a beautiful job. Now, I can't take credit for everything on this. When I got it, it was kind of like a trade-in on another boat. So a lot of the work was actually done in terms of like linkages and control surfaces. Basically, I finished everything up. I outfitted the cylinder, did all of the final linkages, did all the trimming, all of that fun stuff. But this is all ready to go. And man, you know, I am really surprised at how good of a performer this thing is on and under the water. So, you know, typically these modern boats don't turn very well. They don't respond to pitch very well, but they are typically very fast. This is a fast boat, but I will say that because of these, you know, flying rudders, top and bottom, that you can see right there, it responds really well to rudder commands. Pleasantly surprised. It's a beautiful performing boat, and you know, this is circa 1960s British submarine design methodology, and you know, it looks pretty cool. I'll have to say, I like the British boats. They do a good job. And you get the more modern ones like Vanguard, for example. They look so organic. You know, they remind me of like a whale or something like that. But I'll have a video of this posted up in the next day or so. This one's going off to Thailand. It was a quick project getting that all done up. I'll be boxing it tomorrow, throwing it in the mail, and getting it off to my customer there. But you know, just a brief overview. OTW hull, OTW cylinder, nickel metal hydride battery pack right there that powers everything. It's all on 6 channels, so beautiful little boat. I love it. Hey, if you've been following me, if you subscribe to my newsletter, and hey, if you haven't subscribed to my newsletter, what the heck, guys? Come on, man. It's free, and you get all sorts of cool updates on my website. It's only once a month. It's not like I'm spamming you or anything. But I posted this story. I was dealing with this guy out of the UK, and he wanted to trade in this Ark Model 212. It's complete kit with the hull, all of the like cylinder and everything. And I'm not overly familiar with that, and I'm not overly excited about the idea of these Chinese you know, components. Typically they're not exceptionally high quality, but hey, whatever. I made him an offer that I thought was fair, and he's like, hey, yeah, let's go ahead and let's take a look at how it was shipped to me. There we go. And so this bag, this literal gym bag, was thrown into a cardboard box and mailed to me from the UK. And I'm not even upset about that. What I'm upset about is how it was packed inside. And there you go. That should survive well, right? Everything's bent and broken, and I wouldn't even have been so upset about that, except he did such a crappy job trying to put things together. Like, look at this connection. Like, what is that? These random loose wires, some sort of Mickey Mouse connection for main power going to the balancing port of a LiPo, not even the main power port of a LiPo. And then he seals everything with like silicone. And then the cylinder, which is inside, I'm not even going to pull it out, there's like melted bulkheads. And when I asked him about it, he's like, oh, well, that was from a charging accident and it melted everything inside. So suffice it to say, I had some choice words for him and basically told him I wasn't interested in the boat anymore and he could have it back. And he said, well, throw it in the garbage. So I don't think I'm going to throw it in the garbage. There's still some decent stuff in there. Maybe I'll give it away. Maybe we'll talk about a draw for the Ark Model Abortion. Hey, it's free. And for somebody who wants to get into the hobby, who has time and patience, there's some good stuff in there. You could probably make it work. Who knows? But that's an Ark Model 212. As it comes, the hull is actually pretty cool. It's in this like super durable nylon plastic. You could literally drop kick it across a football field and nothing would happen to it. But the detail's not too bad. I mean, it's scribed in super deep. So from a distance, actually, you can see all of this stuff. It looks really good. There's a great like nylon prop that's super accurate in there. And then the cylinder is probably salvageable, but it is what it is. It was a learning experience. And if you take anything away from this, if you ship a boat or have one shipped to you, ensure that it's packaged properly. For heaven's sakes, do not put it in a gym bag. Toss it in a box and mail it to the new owner. Bob's tip of the day. Let's talk about cylinders. I have people who email me all the time. They're like, hey, I just downloaded your 3D files and I'm 3D printing these cool submarines like the Redoubtable or the Astute submarine, and I'm going to build my own watertight cylinder for it. I don't know anything about RC submarines, but it doesn't look that hard. All right. Here's the facts of life for people, all right? Building a watertight cylinder is not a simple endeavor. There is a tremendous amount of engineering and experience that goes into the creation of a successful and reliable watertight cylinder. It may seem simple enough from the outset, but the devil is in the details, so to speak. And what I am going to say is, if you are a beginner just getting into the hobby, do not, by any stretch of the imagination, anticipate that you are going to successfully or cheaply construct a functional and reliable watertight cylinder for your project. It will not happen. It may be that you will build one eventually, but you will find that your investment in time, energy, and resources vastly outweighs what you would have paid just to buy a ready-made cylinder from the outset and had it running, within a few days or weeks of purchasing it versus all of the other problems. So bear in mind, absolutely it's possible for certain people. It is completely feasible to build a complete watertight cylinder, even if you haven't done it before. However, for the vast majority of people who have not undertaken such a project previously, the odds of success are exceptionally low. Even if you succeed at the end of the day, I would be willing to bet you've gone through 3 or 4 different revisions, wasted a lot of materials, and invested hundreds and hundreds of hours in research and development to create your watertight cylinder. So weigh that against buying something that's ready-made and professionally engineered and make the decision. All right? That's Bob's second tip of the day concerning constructing your own watertight cylinder. I think once you start actually adding up all of the costs of the components and adding your time, energy, and frustration, you'll find that just buying something is probably the better path to go. I just saw someone say, I can do it, you can do it too. You did it. The vast majority of people can't. Trust me, I deal with hundreds of people a month. The vast majority cannot. Cannot. I have spoken. All right. Building your own watertight cylinder. And by the way, I found that leveraging 3D printing, and I can hear David Merriman rolling over in angst all the way from here, is an exceptionally valuable tool because you can design everything out, get all of your fitment and everything in there, and then print it, and typically it works quite well. So 3D printing is an absolutely viable technology for the creation of a watertight cylinder. Just make sure you use the appropriate materials, and bear in mind that in my experience, you are going to be printing something that is going to be slightly larger than how you designed it, just as a nature of the 3D printing technology. So keep that in mind when you're building in tolerances. All right. Cylinders. Let's keep talking about cylinders. You know, one thing that irks the heck out of me is people saying, hey, can I build a charging port into my bulkhead so I don't need to open it up every time I recharge my batteries? Yeah, absolutely you can do that. But I'm going to call you a lazy SOB. There is a reason for opening up your cylinder after each and every run you make. Number one, you're going to be inspecting things for water ingress that you may not necessarily need or be able to see without opening up the cylinder. Number two, if even a drip or drop in there goes unnoticed, if you leave that sitting on the shelf for weeks or potentially even months, that little bit of moisture inside the watertight cylinder can corrode exceptionally delicate RC electronics, and you'll find that eventually over time you're going to have a failed component. So there's multiple reasons for opening up your watertight cylinder after every run, pulling the battery out and charging it up that way. All right, so bear that in mind. That is exactly what you want to do, is open up your cylinder after every run, and I would actually store it in an opened position, even if you just leave it kind of cracked open and apart, so there's like a 1/4 inch gap so you can get a little bit of airflow in there. All right. Mr. Warrior said, you know, for the engineering, the watertight cylinder fun is in the trying, testing, revisions, and repeatable successes. You're a kindred spirit. You know, that is where I get my enjoyment out of it as well. The issue is that not a lot of people can make it past that try, revise, repeat loop. And unfortunately, if you're in a situation where you're on try and you've got it in your boat and your boat sinks, you're done. The odds of you saying, oh, well, next time it will be better is very, very low. All right. So you do not want to risk an expensive RC submarine with a homebrewed watertight cylinder that you're not 100% confident in. All right. All right. Building a watertight cylinder. Charging without removing the end caps. Yeah, don't do it. Let's talk about my build queue. You know, what I'm finding challenging right now is this balancing act between supplying everybody with parts, finding new parts to offer, maintaining inventory, new product development, and being able to build customer boats. So the issue is right now, I about 2 days ago did an audit on my build queue, and I let all my customers know where I'm at from a realistic perspective. As it stands right now, I am booked out to March of 2021. And that is anticipating approximately 30 to 45 day turnaround for each build that I do. This German Type 21 is being a real bear. That's going to end up taking me probably into April, I'm thinking. We'll get that figured out, but I've got like 14 boats in the build queue right now. I am going to say I love you guys. All of you thus far have been exceptionally understanding and patient and willing to wait for a quality build. So more than anything else, all I'm saying right now is thank you very much for your patience. Hopefully I don't disappoint you. Stay tuned for updates on the builds as they come. A few notes about what I've got coming up here. That big Type 21 is finally going to end up done, and I've got a deadline in place because it's going to end up on a truck that's already been booked going from here back up to Canada. Montreal, Quebec in Canada, for those of you who don't know where Montreal, Quebec is. After that, we're going to be moving on to a very cool 48 scale German Type 7 with a bunch of bells, whistles, and fun features on there. We've got a Blueback build, we've got a Seawolf build, we've got a Sea View Concept 2 build. If you guys haven't seen that, look up DeBoer Models. He's got Dennis DeBoer has a Concept 2. It's his imagining of the Sea View in its next iteration. And it's very, very cool. So I got an RC build of that one slated as well. I've got a Gato build, another Type 7 in 48 scale slated, a Seehund in 1/17th scale. That's from Otto out of the Czech Republic, his kit. That's, by the way, all 3D printed. So very, very cool. I got a list basically on the custom build section of my website where I kind of keep everything all in order where it's going. So again, that's where I'm at. Thanks for your patience, and look for some cool things coming up in the nearish, well, in the future, let's say, starting in the nearish future and going into the faraway future. What else we got going on here? Did Request ever see water? I don't know if the Request ever saw water. I don't know what you're asking. Sequest? No, but I started. I rebuilt the rear engine nacelle to accept a quart nozzle for both pitch and yaw. That I would consider to be a personal project because nobody as of yet has commissioned me to build one, and therefore I can't fit it in my build queue. I wish I could undertake personal projects of my own. That would be very cool. I would love to do such a thing. But hey, if anybody wants an RC Sequest, let me know. We'll put it in the queue, and no matter what, it'll end up happening. On projects, hey, let's talk about something really cool. Now, for those of you with builds in my queue, don't get upset because this is actually something that takes virtually no time. This is a 3D digital file. See if you guys can, where'd it go? Identify this guy. 1/10 scale, not typical subject, but I've done one before in 1/8, if that's a hint or a clue for you about what this is. Looking familiar? Any guesses? Come on, I know you guys know. You're just teasing me. That look good? No? Nobody knows? Should have made it like a contest and nobody would have won and I would have kept the prize for myself. No? Yeah. Ah, Ed, there you go. 1/10 scale, a little bit more feasible than the 1/8 FX models version. I bought these 3D files. I'm 3D printing them right now. This is PLA Plus. I tried this in standard PLA, but I'm not happy with the print quality on it, and I'm going to reprint it again with the PLA Plus, which is, my printer seems to like a lot more. And this, by the way, is super rough. It's like literally off the print bed. It's like all rough and nasty, and I need to clean it up. But the Alvin was a great performer. For anybody who wants to take a look at a really cool video, look up my Alvin build on my YouTube project. I've got a few, and the final one is the cool one that kind of goes through the final sort of setup for it. And actually, I'm glad Ed is here. Hey, Ed. Some of this might look familiar to you. Hey, these are, I think, my new favorite large submarine methodology for watertight components. This is a series of watertight boxes. These are actually going to be used in that big 48th scale George Washington Carver. Hey, let's take a look at what's inside. Did you see how easy that was? Hold on, let me do it again, just because it's so cool. Sealed, open. Eat your heart out, Engel. So this is the motor compartment. We've got rudder and rear dive plane outlets there. We got a receiver, speed controller, and a big ass beefy motor that's going to be turning that big 4-inch prop. Someone said old school. You know, honestly, I used to think that way, but in my mind, I am coming around to the thought that this is actually the optimal configuration for a large-scale RC submarine build. Now, we could talk about this for a long time, but there's a lot of reasons behind this, and Ed goes into this on my forums at forum.rc-sub.com. The link is on my website. Check it out. But the idea is that all of these boxes are basically completely sealed and isolated from each other. So if there's any water ingress, you'll notice, again, all of the electronics are mounted high. This box could literally flood 3/4 of the way full, and everything would still function. Not only that, but the pump compartment right here, which I'm still working on, would be unaffected. Unlike a cylinder, whereas if everything floods, everything floods. I like this a lot. And, you know, if you ever upgrade something, you know, you can replace one section. It's a great idea. These boxes come pre-made, rated to 80 feet of depth. 80 feet of depth. That is pretty damn cool. Someone asked about this hose here. This is my antenna methodology. This is the receiver antenna that goes in here, so you can stretch it out the entire length of your boat for maximum reception. The other thing that's cool is once this is sealed up, you can pop this cap off, you can blow into it, and you can test for leaks. How cool is that? You don't have to wait for the water to get in there. Matthew asked, where can you get them? eBay and Amazon. That's what you're after, dude. Again, check out my forums, all right? That is where you want to go for all of this information. Ed has a beautiful set of posts on there about his big skipjack and his utilization of these individualized compartments for the construction. And I am sold. Not only is this going to be utilized for this big George Washington Carver, which, by the way, I'm not building out. I'm just building these. These are almost done. They'll go off to the customer, and he has to do all the hard work. But they are also going to be utilized in my beast. So what we've got going on here, this is the big German Type 21 1/30th scale. This is the design methodology that I've got going on right now. Here's the motor compartment. Same idea. We got twin motors, sealed compartment, everything completely removable. And it just fits, or it will fit in there just like that. Twin ballast tanks. They're going to be utilizing solenoid valves to vent and an air pump to blow. And I've got a pair. Now, if you guys remember, I had a 3D printed bow thruster assembly for this thing, okay? I don't know what I was thinking. These are a pair of Seaflow 1100 gallon per hour bilge pumps. And I just got two, one for port, one for starboard. And that is going to be my bow thruster assembly in this boat, okay? So this is the design methodology that I've decided to go with, thanks to Ed and his beautiful article on his 48 scale skipjack. So we're making great progress on this. Here's a little preview of the linkages for the bow planes. Those are going to work really, really cool. Functional torpedoes, functional bow planes. It's going to be cool, cool, cool. All right, let me back up here. I had some comments that I ended up missing. Some of them were like completely off topic. Sub driver plus for 1/72. Don't know what that means. Ed, you're crazy. Oh, I see. You're talking about what scales and all that fun stuff. Old school. No, that's not old school. All right. The best ballast system to use to give the most realistic dive and surface. Well, this depends upon your definition of realistic. Is it in the performance of the boat or the actual technology utilized? Now, if you're talking about technology utilized, well, then you're going to be looking at a compressed air ballast system that would basically, at the surface, utilize an air compressor to fill an air compartment with pressurized air. The boat would dive, and then you would utilize said compressed air to blow your ballast tanks and resurface, engage your air compressor, and resupply your compressed air tanks. A lot of negatives to that system in that it is power intensive, noisy, and you only get one or two blows for each one of those cycles. So there you go, realistic. Is that what you were after? If you're looking for in terms of performance, I would say you're looking at maybe a gas ballast system where you've got a reservoir of liquid air. You vent your ballast tank, all the air comes out, your submerges, and then you blow the ballast tank literally with the liquid air, purges the tank, and it floats to the surface. So there you go. Per your word definition, realistic. That would be my assessment for ballast tank technology integration. All right. Let's see here. Status on the 7-foot Nautilus. You must not have watched my video very closely. I'm not building that thing out. That thing needs a boatload of work, a literal boatload of work. I sold that as a project to a gentleman who tragically had his 7-foot long kit stolen years and years and years ago. I've informed him exactly about what this thing needs, and he is completely cool with all of the work that's going to be necessary to be undertaken. So it is going to be sold as is and where is to that particular gentleman, and away it goes. Let's see here. Let me clarify. I mean dive and surface on an even keel or level. You're talking about the ballast system, diving and surfacing on an even keel. Every ballast system, if you trim your boat properly and put your ballast tank in a centralized location at the center of buoyancy of your boat, will submerge and surface your boat on an even keel. That is not a concern. The main concerns I think that you're talking about is the trimming of the boat, where you put your lead, where you put your foam, and that is going to affect the boat in surfaced and submerged trim. I have many videos about that on my YouTube channel. I have a tremendous article in my blog section of my website called 3 Simple Rules for Trimming Your RC Submarine. If you have not read that, I am quite proud of it. It's the methodology that I utilize for trimming all of my boats. 3 simple rules. Take a look at that. It's on the blog section of my website. Okay? How do you get Lafayette to surface evenly with a piston tank? Good question. All right, so for those of you that don't know, Lafayette is a kit from Engel of Germany, and it utilizes a single piston-style watertight cylinder to submerge and surface. Let's use a visual example. This is a gas-style ballast system, by the way, an old D&D miniatures unit. There's a gas reservoir right in here, the linkages for venting and blowing inside. But we're not talking about that. We're talking about a piston ballast system. So let's pretend that this is the piston ballast system just right here from my hand forward. All right. Inside you would have a plunger, for lack of a better term, and it moves forward and back just like a syringe. Okay. So for example, if this was kind of open, for lack of a better term, to the inside of your watertight cylinder, as this pulls back, it sucks water in, this fills with water, compresses the air in the dry section of your website. All very cool, you say. That sounds very wonderful. However, you'll notice that as it pulls in, now we have water right here. So it's heavier on this side. And then as you pull back, it evens itself out. So what you find with these single piston tank boats is they're going to surface and submerge, kind of like this. They'll start and finish at an even keel, but in the middle, they're going to be out. So they are basically designed to operate only in completely full or completely empty states. You can get away with a little bit on either end of that spectrum, and it won't be terrible, but you want it either completely full or completely empty. All right. So yeah, that's basically the way that works. And the way that people get away from that is to use 2 piston ballast tanks, so that when they suck in together, and then when they push out together. Everything is completely level. And the cool thing about that is if you have individualized control, you can control the trim of your boat. So you could have one move in just a little bit, and you can have your boat go this way and this way and go that way. And you can make things happen like that. But yeah, basically, those boats do not perfectly submerge and surface on an even keel the entire time, but they end up that way, which is the important part. Is it a good idea to install a tire valve to avoid water entering? I don't know how a tire valve helps to avoid water entering your watertight cylinder. That's a good question, Domingo. I don't know that I fully understand it. So for those of you, I got all sorts of like demonstration thingies here. So here's the old D&E watertight cylinder, and hey, here is a tire valve. Now the idea behind this tire valve was twofold. Number one, when you press the end cap on a watertight cylinder, you slightly increase the air pressure of the cylinder inside. You can depress that valve and equalize the pressure, although you actually want a little bit more pressure inside so that water has a harder time entering. The other thing that you can do, which is more important, is take a bicycle tire pump, put it on that valve, and give it 1 or 2 pumps, and then submerge your cylinder to look for bubbles. Now, you remember this? That is my preferred methodology, okay? I have, unfortunately, for myself, overpressurized using that bicycle tire pump and blown the end cap off of a watertight cylinder. There's nothing holding it on other than friction. So if the interior pressure exceeds that of the frictional value of that seal, you're going to blow your end cap off just like a cannon. It's going to be very cool, but very unfortunate. So the short answer is I don't think you need to install a tire valve. I would go with the tubing methodology. Twofold, you can stretch your antenna out the entire length of your boat. You can put it wherever you want to put it. You can keep it isolated from the electronics. It's nowhere near them. And to test, all you need to do is dunk your compartment in the water, blub, blub, blub. Take that out and blow into it. No pumps, no nothing like that. No connections. You just simply blow and look for bubbles. Simple, simple stuff. All right. Spherical ballast tank. Hey, I talked about that before. Ballast tank size. These are what I am going to be utilizing for the 48th George Washington Carver. I'm going to utilize 2 of these because it is a big ass boat. It's 9 feet long. I'm going to put them together to a large centralized tank. The issue is when you have a large cylindrical tank that is long but narrow in cross section, as soon as you dive the boat or surface the boat, all of the water is going to want to flow one way to the other. Now, you can get away from that a little bit by installing baffles inside, which slows that process down but does not eliminate it. What is an ideal scenario is a spherical ballast tank. In that way, if you've got a ball, imagine a ball, if you twist the ball, the water doesn't move. It stays in precisely the same location. So your center of buoyancy does not change in relation to the orientation of the boat. So if you have the room, that is exactly what you want to do. You want to put a spherical, ball-shaped ballast tank in your boat. The good thing about that is you put a hole in the bottom for water to come in, you put a hole in the top for the air to come out, and it is the ideal shape for a ballast system. So, Ed, if you have the capabilities of doing so, do it. I have never seen anybody install one in their boat yet. I would love to see it, though. I think that would be awesome. Okay. Hey, why don't I... some of you guys may remember my son Logan. He's 17 years old right now and loves computer games. We struggle, I should say struggle. We encourage him to have balance in his life. So while we allow him to spend times on the computer games like most kids his age, we also say that he needs to balance that between family time and physical time. And part of this methodology recently has been encouraging him to work with his hands with physical things. And I find this exceptionally rare because most kids nowadays don't have the patience for that. It's all about instantaneous gratification. And we're getting bad for it too. I'm 43 years old. I know some of you guys are older than that. Some of you are younger than that. But we live in the day of instantaneous gratification, and putting 100 or 200 or 300 hours into a model submarine is not very darned common anymore. But let me get to my point. So I showed you these watertight cylinders. And that is actually for a project that was gifted to me by David Merriman. And some of you may remember seeing this thing. Is that not the coolest thing you've ever seen in your life? It is the Bat Sub. If I remember correctly, this is based off of like a Holland kit, and maybe it was broken or busted or missing pieces, and somebody, and I don't know who it was, decided to turn it into something cool, and cool it is. Man, that is just a fun boat. Like, think about this from a design perspective. This is the magic right here. You've got dive planes and rudders directly behind the propeller. And what that means is you get instantaneous reaction to rudder and pitch control inputs. So this boat is going to be a dream to drive. These were not functional. We are going to make them so. Depth control, pitch control. It is going to be fun, and it's a great size. But Logan, my son, is actually the person who's refurbishing this poor boat and going to be getting it back in operational condition. And we'll be doing a video series on it so you guys can watch his progress. I have sworn I am not going to do any work. I will be consulting only. He is going to be soldering, grinding, painting, everything required to get that thing in the water. I'm super proud of him. Looking forward to getting that information out to you guys so you can see it. That's just a darn cool boat. And I think at the end of the day, once it's all done, we'll see what ends up happening. We may end up keeping that, and it'll be a family heirloom, or maybe, he'll sell it for college, who knows? We will get that all figured out. Now, on that topic, I mentioned instantaneous reaction to rudder and pitch control. Another commonly recurring question that I get talks about the purpose and setup behind dive planes in a model submarine. Now, this is my take on it. You have forward dive planes, you have aft dive planes, all right? There are two common, drop that on the floor, setups, all right? Three common setups. Number one, forward dive planes are fixed, they never move. Rear dive planes control both the pitch and depth of the boat. So they will pitch the boat up, the boat goes lower, they pitch the boat level, pitch the boat up. All right, is this all making sense to you? Those boats are going to be pitching up and down quite a bit, like a porpoise, all right? But they work perfectly fine, particularly in situations like that where they're directly behind the propeller. So the instant you give it throttle, you've got water moving over those control surfaces, and they are going to give you instantaneous reaction. Second setup is even faster reaction, because you're actually going to physically link the forward dive planes and the aft dive planes in such a manner so that when the forward dive planes pitch forward, the aft dive planes pitch up, and the boat dives. All right? So you're going to end up with something that looks like this. This gives you tremendous pitch control over the boat. All right? Sometimes too much. But the advantage is it's simple. You have one servo that is connected to both the forward and aft dive planes, and they are the things that control the pitch of your boat. Now, the methodology that I subscribe to myself, slightly more complicated, but infinitely cooler, all right? And that is front dive planes on their own channel, rear dive planes on their own channel, or acting autonomously. So let's talk about an ideal state, all right? Forward dive planes are going to control your depth. They're going to angle down, the boat's going to pitch slightly, bow's going to get pulled down, the boat's going to begin to dive. The rear dive planes are going to be functioning off of an automatic pitch controller that is going to detect the change in pitch, automatically attempt to correct it, pull that down. So the boat will basically submerge on an even keel. Front planes level out, rear planes level out. Same sort of idea, all right? Is this making sense to everyone? The other cool thing that you can do with that, you can actually integrate one of our DC depth controller units to the forward dive planes. So you dive the boat until it reaches the depth that you want. You take your finger off the stick, and then that forward dive planes will actually automatically move to keep the boat at that depth. The rear dive planes will automatically move to keep that boat level, and you've got an automated boat. It's the coolest thing out there. Now, you don't need that DC unit because the automatic pitch controller can do a good job of keeping that boat on an even keel. And typically, I don't incorporate them in my builds because it's an expensive-ish unit and a little bit more difficult to integrate. You have to drill a hole through the bulkhead for the pressure sensor to have water going into to sense the water pressure differential. But that is an ideal state. Typically what I do for the setup on my VEX radios, I'll have the forward dive planes on channel 2, which is left stick vertical. That dives the boat. And then the rear planes will actually completely act autonomously. You can either have them work only autonomously, and all you need to do is provide the pitch control unit with power, 5-volt power, 2 leads. And the unit will completely function on its own. You have no channel connected to it. It just does its own thing. Now, if you do connect it to a channel, and typically I use channel 6 on the back, and that's an override that gives me full up or full down on the planes. And that allows me to create an emergency dive or an emergency surface situation. So this is what we've got going on right now. Everything's nice and level. But if we need to crash dive the boat, we want this. We want that thing pitched down and diving as quick as possible. So you can override that with that channel. The pitch controller's like, okay, do it, go ahead. Well, I'm just gonna sit here and wait until you're done. It dives the boat, take your hand off. The pitch controller's like, oh my gosh, we're almost standing on our nose. Gets everything nice and level again. So it's a cool way to set things up. If you have the capabilities of putting that on a standard channel, especially if you can adjust the trim, Dave Merriman does a superb job of just dialing in those rear dive planes to get that boat operating at a perfect level keel, even keel. So that's dive plane methodology for you, explained hopefully in a manner that makes sense to everyone. Check my list here. Those are my key talking points. We blew through all of those, and you guys have been really quiet. You bought a dual pitch controller. What is a dual pitch controller? I am curious. I don't think I've ever heard that term before. There's 2 outputs? Interesting. Is the new subdriver brushless, non-reduced? Yes. Wait. Yes. It's utilizing a, hold on. .790 kilovolt brushless motor, outrunner. The trick with these brushless motors is you need them for our applications. Very low kilovolt rating because that basically dictates the RPMs of the motor at full voltage. So we source these. These are great. They work awesome. And they are basically applicable for everything from our 2.5-inch diameter drive units that are going to be all the way up to our 3 3/4 inch once we get those all finalized. This is kind of addictive. Spinning this, by the way. They're pretty cool. But they're non-reduced. And you can do all sorts of cool things. Our new subdrivers are going to be coming with, early versions are going to be coming with an M-Tronics reversible brushless electronic speed controller. The later versions, I'm in final review, evaluation of a programmable electronic speed controller that's like literally the size of a quarter. It's the coolest thing ever. The Mtronics units have built-in battery eliminator circuits. The new ones do not have any battery eliminator circuits, so you need to add a separate one, which I have offered separately. Yeah, so that's where we're at right now. These things are going to move water. I am so excited about that. The new units, by the way, as well, will have both single and dual shaft output options, but all driven from a single motor. So basically they'll be either direct drive for the single screw or through a gear splitter gearbox for twin shaft output. That will be geared down, I believe, 3-to-1 for dual shaft boats, because you do not need anything that hydroplanes through the water for those dual shaft boats, because they got more bite than other ones. Okay. Do you still recommend the 3-inch watertight cylinder with the 3D printed Astute? Wondering how its development has gone. Yes. 3-inch diameter is basically what that 3D printed model was designed for, and that is the maximum opening of the top there to get something in. The cylinder that I recommend for it is actually going to be what we call a 250-300-250, which is a 2.5-inch diameter drive unit, a 3-inch diameter ballast tank, and a 2.5-inch diameter power compartment for the battery. So basically all that means is you need to just put a little spacer in those standardized 3-inch opening bulkheads that come stock with it, and you can do that just with little chunks of plastic. Or I've developed some 3D files that I'll probably be offering you guys. You can 3D print them yourselves, or I can ship them to you. I don't know why, because you bought 3D files and you're 3D printing it yourself, so you might as well just 3D print them. But at any rate, a 250, 300, 250, that's going to be driving it like crazy. It's going to be awesome. And those are available now. So yeah, that's what you're after. New projects. Craig, you're late to the party because I just kind of went through the build queue. We got Logan's project going on there. I got the Type 21. I have the Ark Model 48 scale. That's going to have like sound and torpedoes and like all sorts of cool stuff. So yeah, lots of cool things going on. Have you ever thought about making a deployable buoy antenna for first-person viewing? Yes and no. Everybody is so hell-bent on putting video on their RC submarines. Okay. It would be cool. Absolutely. I can't argue with that, all right? The idea of towing around a buoy behind my RC submarine gives me the heebie-jeebies. It is going to severely affect the performance of the RC submarine. The odds of snagging it on something are exceptionally high, and the odds of another boat, ship, or submarine snagging it are exceptionally high as well. So yes, you'll get the video, but in my mind, the downsides far outweigh the upsides. My personal preference is to put a high-definition self-recording video camera aboard the submarine, just record the video and just get it back afterwards and view it in all of its high-definition glory without it affecting to any significant degree the performance of your RC submarine. My opinion, maybe it's just because I haven't tried it before and I've got sour grapes or whatever you want to call it, but that is my take on it. The answer to your question is no, I have not tried it. Yes, it is completely possible, and I think a lot of people would be super interested in it, but I think in practical application, I don't want to be towing, another buoy around on my submarine. I just don't want to do that, okay? Kilovolt. I already talked about that. I told you 790 kilovolts, which means they're going to spin for sure. So you're going to want to scale things back with an endpoint adjustment probably through your radio, likely 50-60% depending on the boat that you have. But it's hard to find something lower kilovolt than this. Very hard. Okay. Larger power conduit. Don't know what that means. Am I going to test 433 megahertz? Nope. Done with it. I will tease you, though. I'm going to tease you. Not even David Merriman knows about this yet because I haven't a chance to talk to him because he's been so busy. I don't want to distract him because he still owes me about like 18 bajillion sub-drivers and he needs to be very busy and not talking about other things. Right, Dave? Okay. I'm dealing with a friend who is an electronics master, and we are working on a new remote control technology specifically suited for subaquatic control of craft without the use of radio waves. That's all I'm going to say about it. It is going to be the coolest thing ever if we can pull it off. It is going to offer tons of functionality and programmability that is not currently feasible with RF technology, certainly not anything in the gigahertz range. So stay tuned. It's not like this is going to be happening tomorrow, but it is a solution that we're working on right now. It sounds absolutely feasible, and we've got prototype parts coming to us for testing. Will your new system work with the radio stuff out there? Nope. And that's all I'm going to say, only because that old stuff is redundant and it's not going to be useful anymore. And the new stuff is going to be far more powerful and easier to get a hold of and cheaper. So there you go. You guys can guess. Keep going. I won't even tell you if you're right, so just keep on going. No, you don't need no new servos. So I'm strictly talking about the communication protocol. You'll be using all the same servos, all the same gear, all the same components. It's just how it communicates back and forth is going to be different. All right? Bandwidth to be proportional. Yes and no. We'll talk later. I'll confide in you, but not everybody else, because you know what'll end up happening is they'll bug me for like forever for details. And then it won't happen for like 8 or 9 months and everybody get grumpy. So that's all I'm going to say. All right? But it's happening. Oh, by the way, good news. I did manage to come across a stockpile of additional VEX radios. So I've got, I think, 70 more 75 megahertz radio systems. So this is going to carry us through, all right? So a little bit of breathing room. We've got radios for people looking to get into the hobby, to replace radios, to work with all of our gear in 75 megahertz, so we can actually dive, unlike the gigahertz systems where you can troll around on the surface and pretend that you're a submarine. I'm just bugging you, Ed. I don't mean anything by that. Yeah, so there you go. That's where we're at. We got radios and we got new radios and lots of cool things going on. That's it. Haven't seen very many more questions pop up there, and we are at 58 minutes and 31 seconds with 62 people aboard. I think that's a lot. I think it's pretty awesome that you guys stop by and view my channel. Hopefully you learned something. I certainly enjoy doing this. Between now and the next one in March, by all means, send me questions in advance. If there's something you specifically want to talk about, if you want to make it like a focus of my next YouTube live broadcast, send me in advance. Otherwise, I'm just going to make stuff up and do whatever I want. All right? Which maybe some of you are cool with, but rather than springing on it, at the last second, give me some heads up so I can pretend I know what I'm talking about by researching it in advance. All right. So with that, I'm going to sign off unless there's any last minute questions. You've been listening to Bob Martin, and I go by the moniker of the RCSubGuy with the NautilusDryDocks.com. Again, thanks to every single one of you guys. You are awesome to deal with. patient people with passion for the hobby. Make it easier to get up in the morning. Thanks a lot, guys. Check out my YouTube channel. Check out my website. Check out the products. Let me know if there's anything I can do for you. Again, Bob Martin, the RCSubGuy with the NautilusDryDocks.com. Have a great evening, and we will catch you next time.